Hello, and welcome to all of you joining us today on the fourth session of the AI and Leadership course brought to you by the School of Computer and Engineering Sciences from the University of Chester. I know some of you may be joining us for the first time, and yeah, we're going to take you through some introduction, and then you get on top of exactly what we are presenting to you today. My name is Toyosi Oniloye. I'm the deputy head of school at the School of Computer and Engineering Sciences, and I'm joined here by my co-host Alex Fenton and other colleagues and a guest speaker that will be taking you through what we have for you today. So without further ado, I'm going to hand you over to the rest of my colleagues and the presenters we have today to introduce themselves, and then we'll take you further on what you have today. Alex.
Thank you so much, TLC. Excited to be back. We've had a bit of a break for a few weeks, haven't we? So it's nice to be back with a bang for this one, with some brilliant speakers here as well, both coming from the University of Chester's computer science department and also from industry as well with Dora. So it'd be nice just to hear from a couple of these guys very briefly, just introducing themselves. Professor Bin, if you could start off. I think you're on. Thank you, Bin.
Hello everyone, I'm Bin Yang. I'm professor in electromagnetics and measurements. So I worked for University of Chester for nearly 9 years, and I think we developed very good programs including AI and electronics. So I'm very excited to introduce 3 of my research topics in today's session.
Brilliant, Bin. Thank you. And Adam, thanks for joining us.
Yep. Hello, my name's Adam Morrow. I'm a Knowledge Transfer Partnership Associate and part-time PhD student. My project is partnered with Passion for Life Healthcare, and I work on embedded AI for medical devices. I also graduated from the University of Chester, so I am an alumni, and I graduated with a Master's in Electronic and Electrical Engineering.
That's brilliant, Adam. Thank you so much. Look forward to hearing a bit more about that project soon. And Dora.
Hello, thank you for having me today. I'm Dora Moldovan. I am the Chief AI Officer at Tomorrow Group, a group of companies focusing on digital marketing, influencer marketing, and AI. And I'm also co-founder of Breda, which is the group's AI consultancy. I'm a proud owner of a computer science degree, and it's so good to be back to school. Thank you for having me.
Well, we're really pleased that you've all joined us, and look forward to hearing from you all soon. I'm just going to put you backstage for a minute while Toyosi and I just give you a few updates about the course and what's been going on at Chester before we get to the important stuff to you guys. So we'll see you very soon. Thank you, guys. Okay, Toyosi, right. So here we are already. Can you believe we're on session 4 already? It's flown by, hasn't it? And despite a bit of a break for a few weeks, it's nice to be back, Toyosi.
Yeah, it's nice to be back, and I believe the topics we have today are taking us deeper and wider into this course. So yeah, looking forward to it.
Yeah, definitely. And I think some really good case studies. I mean, this is exactly what we're trying to aim for here. We've got one of our top profs who's working on live projects with organisations, along with Adam, obviously, who's at the thick end of that as one of our graduates, and then Dora's, head of AI for a really cutting-edge company. So it's exactly kind of what we're trying to aim for when we're delving into these case studies, right at the cutting edge of this stuff. So it's exciting. So just a really quick reminder for everybody, if you've not done so already, you can register for free. We're still accepting registrations for the next few weeks. It's going to be 5 one-hour sessions between July and September with our experts, with a live discussion and Q&A, live stream recorded sessions to Facebook, YouTube, and LinkedIn. And you can access all those sessions on our learning management system, along with a final quiz and certificate as well. The certificate's looking like that, Toyosi. This is now all wired into our system and ready, and it's just down to us to just create the quiz, which we'll do so after the final session next week. Yeah. That session is going to be the final one next week. Session 5 is going to be the 9th of September at 10 a.m. and it's going to be Eddie Borup. Eddie's got a really interesting profile, actually, Toyosi. I was just looking through his profile, so we'll look forward to that one. Yeah, and our own Professor Catherine Welsh as well, talking about some of the environmental impacts as well, Toyosi. But I've been seeing this all over the news and LinkedIn recently about the wonderful National Student Survey results from your school, Toyosi. Can you tell us a little bit about that?
Yes, thank you very much, Alex. And recently, the NSS results were out, and we had an amazing result, particularly within the computer science course. And of course, this tends to spread across other courses as well. Our students tend to reflect the fact that we present the courses, different courses that we teach to them to the best standard and to the best of our ability. And this has been reflected in the NSS results. And it actually comes to show you that my colleagues and I, we are here to deliver. We are actually here to ensure that our students get to the top of their possible capacity within the career that they are building with us here at the University of Chester. I know the NSS covers for the undergraduates, but you do know that we teach both the undergraduates and the postgraduates, so we deliver across board. Yeah, thank you.
And we've got international and domestic students, both at undergraduate and postgraduates. It's really fantastic to see those results, Toyosi, and I hope this course has given people a bit of a flavour about how computer science and engineering is working at Chester as well. But yeah, so we've had our 5 minutes now, Toyosi. So without further ado, let's bring Bin onto the stage and ask him to present some of the really interesting work and ideas that he's doing. So hello, Bin. I'm just going to add your slides on as well, if I can find those. You may just need to add those again, I think, Bin, if that's all right.
Okay. Sure.
So Adam was mentioning earlier, he's working on a knowledge transfer partnership, a KTP. Really interesting projects, these as well. It's a government scheme that's been going for kind of almost half a century now, believe it or not. I think about all the changes that have been happening, but really wonderful opportunities for organisations to work with research intensive places and higher education universities as well. Tackling kind of real world problems. So, Bin and Adam have been working one of these as well, which is really exciting. So I'm looking forward to hearing a little bit more about that.
It's what's the issue with my file.
Okay, I'll tell you what, Bin. Let's while we rectify that, should we ask Adam to come and present first? Is that okay, Bin?
Yeah.
Okay, Adam, we'll ask you to present your slides first while we just sort that technical issue out. If that's okay, Adam?
That's perfect, yeah. So welcome to my lecture on the optimization of artificial intelligence for smart embedded systems. Just some background, as I mentioned before, I graduated from the University of Chester with a master's degree in electronic and electrical engineering. This was actually a kind of a hybridized degree with computer science. So I took modules such as artificial intelligence. The bottom right is a piece of coursework I did in quadcopter drones with robotics module. Top right is 77 gigahertz radar. And thanks to the University of Chester, I learned a lot of skills in artificial intelligence, but also leadership and management. And I've taken that with me in the medtech industry as I work with electronic medical devices. So I just want to talk a brief bit in the background of artificial intelligence and specifically deep learning, because this is understanding how deep learning works is very important for optimizing for designs. So the one key concept of deep learning is that the layers learn hierarchical representations automatically. And what that means is layer after layer, you're going to extract an abstract representation specific for your task. And you're extracting these representations layer after layer automatically, rather than more traditional methods where you might be doing some feature engineering work. This has high accuracy and flexibility, but on the flip side, it has high computational costs and training data requirements. So when you are designing systems with artificial intelligence, you have to consider how much training data do we have? How much validation data do we have? Do we know it works? Do we require any feature engineering? For example, if we're looking at acoustic waveforms, microphones, is it better to transform to the frequency domain? If you look at training, you have to wonder how much compute do we have? Are you using something like Google Cloud, for example, cloud computing? Do you have a data center with a bunch of GPUs? You have to wonder what the cost of training is and take that into consideration for your design work. And then there's inference as well, which is actually very interesting. You have to think about where the model's going to run. What's the size of the model? Is it only cloud only, or can it fit on a laptop? Can it fit on a mobile phone? Can it fit on a 10-pound chip that you can manufacture? And what data is required for your input? There is a significant difference between having video for your input and then maybe having a few values you extract from sensors. So just to go over the uses of deep learning, convolutional neural networks, image classification, it's essentially a kernel that swipes over the image and it's pulling out representations of the image. Very useful for object detection and pattern recognition. In the example here is the picture of a cat that's trying to classify, but it's any two-dimensional representation. So if you have an audio waveform and you convert it to the frequency domain and you plot frequency against time, that is two-dimensional data and it works very well. On the bottom, we have recurrent or long short-term memory neural networks. As you can see here, the output is not only dependent on the input, but the state of previous inputs as well. And that's very good for temporal representations. How does the representation of the data change against time? So that's useful for forecasting, for natural language processing, when you transform words into some sort of numerical representation and seeing how they vary against time. So armed with these sort of use cases of deep learning, we can see that it actually maps into my industry of medtech. For example, you could have some sort of neural network which determines when to apply a positive airway pressure to someone with sleep disordered breathing. People might struggle to breathe during sleep, and so they require positive airway. Another example is blood sugar and diabetes, trying to measure that for diagnosis and treatment. Even something like a MRI machine and trying to find tumors in the brain, for example, and using artificial intelligence for that. There are several key aspects you have to consider. Compute. Are you using cloud computing? What's the cost of cloud computing? What's the cost of taking videos, for example, and streaming it over the internet? Because someone has to pay for that. Is your AI software as a service, or is it a standalone product? Mobile phone computing, you have to consider how reliable is the mobile phone? What happens if there's a software update in the middle of diagnosis, for example? On-device computing, how much does it cost to manufacture it? What's the energy consumption? Is it battery powered? You have to think about performance as well. So in sleep disordered breathing, a very common way to diagnose the problem is to count how many cessations in breathing there is per hour in total sleep time. So you have to consider what happens if the algorithm gets an event wrong? How many events wrong does it have to take in order to sway the diagnosis? What's the threshold between mild disease and moderate disease versus severe disease? What happens if the general practitioner gives a wrong decision based on that diagnosis? There could be the difference between someone receiving treatment and not receiving treatment. You have to consider data protection. Are you working with sensitive data? Is it personal identifiable data? What's the intrusiveness of your data collection? And security as well. Are you streaming over Wi-Fi? Is it a home network or is it a professional IT network at a hospital? Is it through Bluetooth? Do you have a device and a Bluetooth on your mobile phone? Is it on-device collection? So one technique for the optimization that I'm going to talk about is transfer learning. And this is essentially a way to rapidly prototype your machine learning algorithms as a way to reduce the amount of data you need, because data collection, especially in the medical industry, is a problem. It is going to be expensive and time consuming. And if you're a small to medium enterprise, that is a tremendous impact onto your development. What transfer learning does is it takes a pre-trained model from someone else, a high performant model, and you take that as a base, and then you add on your own custom network to the end. And what happens is it speeds up training, especially if you have a lack of data, because you're taking the early layers, which are the more general abstractions of your representation. And then you're adding your later layers, which is your fine tuning for your specific task. You do expect an accuracy drop, but the benefit is tremendous, especially if it's rapid prototyping or even for the final product if you're a small to medium enterprise. Another method is knowledge distillation. Just a bit of background for knowledge distillation. When you try and classify, for example, an image of a dog, yes, no, is there a dog? It's a binary decision, 0, 1. But models don't output binary, they output a certainty value between 0 and 1. What was found was that a teacher, a larger, more accurate model, the certainty value can be used to train smaller models called students. The benefit of this is that you have a student model almost as accurate as the teacher, but significantly smaller. And then you take the smaller model, and it's the difference between having the must requirement for cloud computing or having the option to put it on a local device like a mobile phone or a laptop or even a small wearable device. So it's a very popular choice of reducing model size. So here's an example from my project, which is automatic snoring treatment. We have a microphone, which I've shown a picture of a microphone here, but in reality, it's a very small chip on board that collects data. And we transform that into a spectrogram, which is time and frequency. So two-dimensional. If it's two-dimensional, use a convolutional neural network. The neural network runs its inference. It runs on a 10-pound chip at the center of the board. So very low cost, energy efficient, and we don't have to require sending data to the cloud and then getting a result back. It all happens on device. And then we want to determine, is there a snore? If there is a snore, you could maybe do positive airway pressure treatment or maybe electric nerve stimulation treatment. So here's the example of the snore classifier. We've got a classifier because we're classifying whether it's snore, breath, silence, or other. On the left-hand side, you can see the spectrogram, time, frequency, magnitude. It's two-dimensional data, so it works great with convolutional neural networks. With only 2 layers of a convolutional neural network, we've extracted the correct representations to determine the decision of whether it's snore, breath, silent, or other. And this is trained on about 5 hours of snoring data. The more data, the better this is. But as you can imagine, going through overnight data and trying to pick out snoring events, it's time consuming, it's expensive. So I've got some results here, and I'm not going to go through the results in excruciating detail, but I wanted to show you a model compression technique. So F1 score is a measure of accuracy, which is 83%. The model size is 26 kilobytes, which seems small, but it's the difference between 2 chips, 1 pound difference. If you're making thousands of these devices, that's very expensive. Quantization is the principle of taking a 32-bit floating point value and changing it or mapping it to an 8-bit integer value. It reduces the size of the model by 68%. Now, you would think that by reducing the precision by that much, there would be a tremendous accuracy loss. But the complexity of the AI algorithm is in the layers. It's in the representations that you extract layer after layer. It is not in the precision of the weights of each and individual neuron. So there's only 0.3% accuracy reduction, virtually no accuracy reduction. If you think about making a device, if you're only making 10 or 100 of these devices, maybe you want that 0.3. But if you're making thousands of these devices, 68% is the difference between requiring additional flash storage on PCB. That's an extra chip, that's extra surface area on the printed circuit board. It's the difference between a 4-layer board and the 6-layer board. It all adds up into cost. And so this is design optimization. So this was a demonstration of embedded AI, but I'm going to explain what was the video. It is essentially a wearable device, battery powered, which accepts the snore as an audio. It rejects other noises like me speaking, for example, and it triggers an electrical nervous stimulation. So here is 2 electrode pads, and these go on the neck here to stimulate the hypoglossal nerve. This pushes the tongue forwards. So if you're having obstructive sleep apnea, which is upper airway collapse in the middle of the night, this would be able to prevent that. So that's an example of the sort of devices that we could use with embedded AI. I also want to talk about agile research and development. If you're in the software development domain, you cannot escape the term agile. Agile essentially operates on the principle of I know it when I see it. What does that mean? Well, what that means is that the customer that you are trying to give a valuable product to can't define what the product is without first seeing the product. So how can you develop a product if they can't define it? It's a bit like a chicken and the egg situation. In traditional manufacturing and design, we develop a product design specification. And there is a tremendous amount of work going through each of the data sources to define the product. Suppliers, supply chain, manufacturers. In medical device development, speaking to the consumers is not only important design, it's actually legislation. It's in the international standards. You have to speak to your consumers, and that is a design input for your device. In Agile, like for example, Scrum, what they do is they do 1 month of work, a sprint, and then they give it the device to a consumer, and they monitor behavior, they analyze consumer behavior. Sprint after sprint, you're giving it to a representative of the consumer. They give feedback, and what you're doing is you're trying to maximize value. You have to be open to changing the plan, but in doing so, by constantly reviewing what you're doing, you maximize the value delivered to the consumers. You can consider the potential value to be the user expectations minus your quality of product. If they have high expectations, but you do not have a product to give them, there's a high potential to deliver a nice product. Also, in the agile development tier, you have to consider the input of research. It's research and development. Research is a data input to your development so that you can maximize the value to your consumers. And that is the end of the presentation.
I don't know, it's really good, really interesting, bit of audience feedback there as well, kind of saying it's really interesting to be back in the session, really, really informative. I really liked that as an example. Do you think with medtech there's more emphasis on the medical sector to make sure that data is secure, protected, accurate, perhaps even more than any other sector?
Absolutely. It's not only in international standards, it's in law. For example, if you are trying to go into the EU market, you have to follow medical device regulations. So the biggest one is consumer safety. You have to make sure it's safe. There's going to be creating a product design specification. There's going to be developing the design. And only then can you verify and validate it in a clinical setting with a clinical evaluation. It's a very expensive and long process, but it has to be done to maintain safety.
Brilliant. I really like the idea of kind of using pre-trained models and an agile approach. Like say, sometimes you don't know what you're trying to develop, so you can hit the ground running pretty quickly and get good efficiencies while maintaining security and all the rest of it. Then that seems like a very sort of a pragmatic way forward. And I suppose that's what KTP is about, isn't it? Applying that research and knowledge and applying that into, embedding that knowledge into the organisation. So that seems like a really pragmatic way forward.
Absolutely, yes. Knowledge transfer partnerships is all about transferring the knowledge to the industry partner. And in our KTP project, it's not just about developing a proof of concept or increasing the technology readiness level. It's about designing the design process. How do we maximize this design process to produce high quality, valuable products?
That's fantastic, Adam. So we've got a real tight schedule. So let's invite Bin now to present his session. Thank you so much for that, Adam. That was brilliant.
Okay, thank you very much, Alex. And so cautious time, I introduce 3 very brief AI case studies from my research. The first one is about advanced driver assistance system. The second one is illicit post security check system. The last one is Adam is done. That's the healthcare monitoring system. So I will quickly and briefly talk about that. The first one is a DAS system. That's self-driving. The full self-driving is a coming stage for the motorway and also for our driving system. But so far, what we are doing this advanced driving assistance system. In the system, we introduce the millimeter wave antenna instead of the camera system. The camera system can see some limited distance, for example, 50 meters, 100 meters. However, the millimeter waves can see about 200 meters up to 1 kilometer. So the seeing distance is longer, so you get more time to do the maneuver and the turning strategy for your driving. Based on this one, we send more data into the car in front of you and around you, and then collect this information based on the point cloud. We call this point cloud. So it's circle. Based on this kind of information, to do a lot of training to decide what is the car in front of you, that is speed, distance, direction, and we get all kind of this information. We do training so to make our car make the self-decision. So for this one, I couldn't show the video, but I just try to compare. On the left is the millimeter wave radar data, and on the right is the simple camera data. So you can see the camera, based on the camera system, the car is slow, but based on the millimeter wave radar system, you can see your car can driving into the full speed. So this is one case study. The second case is about the terahertz security check scanner system. The terahertz radiation is one kind of electromagnetic waves. It has advantages. It can penetrate a lot of materials such as plastics, foam, and cardboard. And also it's safe, it's no hazard to people's health. So based on this one, we work together with a UK company called Vision Metrics. So we work together to design a security checking system. We don't need to open the parcel. We can directly put the parcels under our scanner. So the scanner goes through and we can see what inside our parcel. And then we train the scanner to automatically identify the scissors, oil, and some big dangerous tools. So based on this one, we do a lot of imaging training, and then finally we can automatically identify the illicit items. So we did this experiment in Sheffield Parcel Force International Center. The last one is Adam just talked about. This is healthcare for obstructive sleep disorder disease. So far in UK, we use polysomnography or use some home-set sleep apnea test, HSAT device. So you either have to go to the hospital or clinical test. You need to sleep there, or you have to rent, or not rent. The NHS will send some home-set device to you. You can use for 2 nights. So the whole processing is slow, and also you can see you can get a lot of sensors on your body. That's not comfortable for you to sleep. In order to avoid this kind of issue and also to make the home test simple, so our group is trying to design a sensor on the left of this part. This small sensor, if we put on the abdomen and the chest area. And then we developed the app based on our breathing pattern. Here is the breathing pattern. Based on our breathing pattern to do a lot of AI training. And from this training, we can predict. The first one is predict what will happen. For example, sleep apnea will happen or snore will happen. And also we can monitor the whole night of your sleep conditions. And we can put this kind of information into the cloud, so the cloud can go to your GP, and also the information can be automatically analyzed in your phone, and you can get a conclusion after your wake up. So here's Adam. He did some experiment. The whole system, I can't show the video, but the whole system is purely based on a simple sensor, so you feel comfortable, and also you have a very useful app to record it or predict all kind of your sleep information. So thank you very much. That's all from my part.
Thanks so much for that, Ben. Some really fascinating examples there, and again, really crucial as well. Like we've said before on this code, when people think the masses think about AI, we think about large language models. But I think what yourself and Adam have demonstrated there is that there's lots of AI potential there to solve some really tricky problems, like health problems or security problems, which we haven't been able to do before by combining those things. I really like the idea as well that you can kind of, okay, there might be a medical solution like a gold system, but the fact that we could now develop home systems and utilize people's smartphones and apps and things brings it to hands of users. And I think, we're already kind of, healthcare systems are already overwhelmed. So the more we can develop these type of home systems and social prescribing and things, I think is really fascinating. What did you think, Toyosi?
Yeah, I agree with you, Alex. And I was also going to highlight that with being that the flexibility that the device would bring to the system, whereby if you have someone who has the OSD case, I thought, having to now change where the sleep could actually aggravate the circumstance. But when you have something that helps you to stay within your comfort zone, at the same time, the patient can be examined. I think that's way, to a large extent, it gives the patient some control over the circumstance, which I think is something that is a welcome idea.
Yeah, absolutely. Because a lot of people actually they have the OS way, but they didn't even notice that one. So the product we are trying to develop and already developed is trying to realize this function, so people can quickly get this simple sensor. It's a very small sensor and comfortable to aware. And then during the night, you can do the test. And in the morning, you can get the conclusion from your phone. So that will give you a lot of data analysis and conclusions. Yeah. It's very helpful for self-health monitoring.
I think the fact that we can, certainly in the Western world, the global North, guarantee that most people are going to have some type of smartphone and some type of connectivity really opens up some interesting possibilities, doesn't it, in terms of, people monitoring their own health and so forth. How do you, because you work on these live projects, how do you deal with the fact that there are new hardwares and softwares coming through? Like, are you able to kind of horizon scan for new hardware and software to be able to apply to these projects?
I think for the Adamant project, we design both hardware and software. So that's huge amount of work. And hardware, you at least first you need hardware to collect accurate data, and then you can put this data, and then start to do a lot of filter things and rearrange the data. Finally, you can start to train your algorithm. So it's need a lot of work. So we need both hardware and software.
Yeah, absolutely. I suppose it's those advancements of technologies developing at a pace, isn't it now? New kind of algorithms are emerging, and new APIs and new pieces of code and so forth. So it's going to be interesting to see, how, solutions can be built on top of, those existing kind of, open source softwares or new chips. I think in session one, Toyosi Sylvester mentioned about a lot of these chips are human designed, but what happens when those chips have been designed by algorithms themselves? So it's going to open up some really interesting possibilities for solving some of these challenging problems in medical and in other areas of society, isn't it? I think. Adam, you mentioned about SMEs as well. I mean, I suppose when we think about some of these technologies, we think, oh, it's the NHS, or it's kind of larger organisations with big budgets and big coding teams. But how can like smaller organisations, startups, and SMEs capitalise on these technologies, Adam?
SMEs can capitalize on this technology in multiple different ways. So, for example, with this KTP project, we are working with an SME, and when we design our own hardware, we're looking at new technology, for example, in the chips, to manufacture our hardware and then put our own novel AI algorithms onto the device. There is an extremely long and expensive process to design and validate your electronic medical devices. In this case, you would look towards maybe perhaps Innovate UK, for example, biomedical catalyst grants to support SMEs into going through this process and manufacturing these electronic medical devices.
That's brilliant, Adam. Thank you so much. And on the subject of SMEs, I think it's time for us to bring Dora, I think, into the conversation. Hang on. Before we bring Dora in, we've just got a question from Kenneth. Kenneth's saying, hey, Adam, in building teacher and student AI, can secondary data be used to train AI?
So in terms of secondary data, I'm assuming a primary data set in order to train the teacher and a secondary data set in order to train the student. Yes, you can do it in this way. So you would take the teacher model, pre-train that. It could be from somewhere else. It doesn't have to be manufactured by you. And then take that and on your own custom data set, give the same data to both teacher and student and have the teacher's output support the student's training.
Brilliant. Thank you so much, Adam. Okay, then. So over to Dora. Thank you very much, Dora.
Thank you for having me. And I'm hoping to take you through a case study which my company has executed for one of our clients called Culture 3, and in partnership with TED, the conference company. So let's dive a little bit into what tomorrow is. We believe that the future of value creation for brands is where data, brand, and storytelling connect. To that extent, we are comprising of a group of companies that deal with data, retrieving data, augmenting data for companies, organizing enterprise data marketing and customer data, and then companies that deal with storytelling and with the connection between brands and consumers, such as Disrupt, who are an influencer marketing agency, Bound, who are a advertising agency focused mostly on performance. And then we've got a couple of platforms called Kingmaker and Lumina, which are helping us, the entirety of the group, to navigate different challenges when it comes to data analysis or data retrieval. We're going to focus on the work which Breda has done in this case study with Culture 3 and TED. Now, what Breda do is engineering organizational intelligence. We are a company that create AI solutions by organizing data and applying various techniques over that. We combine AI and systems thinking, so thinking about the business problems rather than just the technical problem, to resolve complex challenges. And you'll see that the challenge that we have taken on in this particular case study is one of a global scale and one that is very, very sensitive to handle. One of the main problems that brands have got at the moment is the modern brand connection paradox, and that is balancing authenticity versus performance. Of course, we know that boards and investors are requiring relentless performance, revenue, profits from brands, but then also brands need to authentically connect to their customers, because otherwise they risk a whole heap of issues, that because consumers are very savvy at the moment and consumers demand excellence from brands. So when we look at the current set of challenges when it comes to brands connecting to those audiences, we're looking at an authenticity crisis where consumers literally punish brands that don't look transparent or real. But then it's also a big challenge in marketing, because to create that realness and transparency requires a huge amount of storytelling and personalization, and that can become quite convoluted. The brand message can be lost or distilled too heavily, and let's be honest, it's expensive. Then we've got the trust erosion. Consumers are turning to brands because, frankly, there is loss of trust in government, loss of trust in institutions. Therefore, they expect a lot more from brands. They are very quick to tax missteps such as greenwashing, shallow purpose campaigns, hidden data use, and that is a big problem in marketing. And then we're looking at attention fragmentation. Consumers are not in a linear funnel as they used to be a few years ago. We are now looking at people's attention scattered across platforms, formats, micro communities. Brands literally have to tailor to meet these consumers in all of these platforms, and that can become huge campaigns with huge budgets being needed. So when it comes to trust, it's harder to build, but it's much easier to break. We're looking at media literacy. When it comes to consumers, they are all literate in terms of the platforms that the brands are on. They can spot inconsistencies between your Facebook campaign and your advertising campaign on YouTube. There is a misstep amplification. People go viral for all sorts of things, but especially when they make mistakes online, especially brands. And then rebuilding credibility takes years. That recovery challenge is huge. So how do we solve this? One of the main things that brands can do in order to solve this is to listen to the consumers. Listen to how they speak and interact with the products and services that the brand offer, probably how they interact with their competitors, and really taking the feedback on board and creating genuine brand connections. Now, that was historically done in settings such as focus groups, surveys. You'd get a sample, you'd understand what those sample consumers are doing. When people are in a room, we know that they get biased by whoever shouts the loudest. So you might get some sort of understanding of what consumers actually want. But right now with AI, we are enabled to understand, listen to, and process conversations at a scale that has never been done before. So let's dive a little bit into how we did that for Culture Tree and Tribe. I'm going to talk a little bit about what the problem was before I dive into the solution. Culture Tree is a branding agency that wants to take their their clients through campaigns that are really genuine and help people connect with key big problems that exist in the on Earth right now. And one of those were climate change. They wanted to understand how brands can talk about climate change or address climate change in a way that doesn't look like greenwashing and in a way that doesn't look like there is inauthenticity in that conversation. So what we did, we created something called RAG LLM, Retrieval Augmented Generation of Information, by feeding an LLM. And now we're going into the realm of AI is an LLM conversation, but that's what we did. We fed an LLM through a RAG mechanism, 14 million conversations from X, TikTok, Facebook, and YouTube. We retrieved those conversations, especially centered around climate change, activism for climate, brands that were posting about climate, key brands that are poster brands for the climate change, and also the other side of the conversation, the the doom scrollers, the climate deniers, and so on. It was an interesting exercise to do, and we ended up with something called digital twinning, understanding what the consumers think when it comes to climate change. This is how we executed the technical side of things, but I'm going to take you through the case study and what Culture Tree and TED achieved through this. We wanted to connect the cultural DNA of the audiences with the AI-powered solution. What that meant is that we were able to then interrogate our system to understand what sort of values, what people actually wanted to be told, or how brands needed to message in terms of climate change in order for that brand to resonate deeply. For example, we had a little case study where we looked at how Unilever produces climate campaigns, and we realized that very quickly that they were not connecting to anyone. The impact and the uptake was very little, because even though the campaigns were very well executed and the content was great, they were not talking to anyone in particular. So we realized that we needed to organize this climate audience into something that we call tribes. We used Marcus Collins's theory about groups and culture, and we called our tool tribe. So what we actually ended up with was a set of 8 tribes locked into culture wars of words. So you can see on the left-hand side, we have the negativity, which is climate cynics, disaster doom scrolling, politically charged debaters, and so on. And on the right-hand side, there is very good traction in terms of activists, eco-conscious trendsetters, techno-evangelists, and so on. People that are actively doing something about climate change, and people who understand this particular issue at the core. Now, why is this important? This is really useful to brands to understand and know, because if you want to launch a product, or you have a campaign that is launching something in the market, and it needs to, number one, not get really bad backlash from the politically charged debaters, but also appeal to someone that is an eco-conscious trendsetter, we can simply interrogate tribe. And you can see here in this particular instance, you can absolutely ask questions, and tribe will reply to you and let you understand how the eco-conscious trendsetters, for example, interact and like to interact with brands. Just wanted to show you a few things that even though the red may be more than half of the conversation online, when it comes to negativity against climate change, there is a path forward. And we are looking at particularly the change makers in the industry at the moment when it comes to climate change are female, and they are Gen Z. We are looking at them at the moment voting green more than ever in the elections. They are making changes. They are using micro changes in everyday life to educate other people on platforms like TikTok, like Instagram. So we believe that understanding things like this and being able to tell stories about climate in a way that is resonating with key people through influencers, through campaigns that are genuine and connect to the values that consumers have, is the way forward. And this is how AI is now allowing us to create these particular beautiful campaigns. That is the entirety of my presentation. Thank you very much.
Thank you so much, Dora. It's really, really interesting. And really kind of resonates as well with some of my research, which is in the kind of sports sector as well, looking at social media and some of the challenges within that. So like English Premier League clubs are struggling to understand, as you say, building trust with audiences, kind of fragmented audiences into micro communities. When you've got an audience of tens of millions, how can you possibly kind of try and respond to people or understand the fragmentation of it? So it's really interesting to look at Tribe and see how that potentially could, shed some light on these quite challenging issues. Because you're talking about, hundreds of millions of social media users. it's almost impossible to sort of manage and understand all that data, isn't it? So I think Tribe looks absolutely fascinating. We've got a comment there. Oh, sorry, Dora.
No, I was going to say, when you have an audience that spans millions, it's really inauthentic to actually assume that they're all going to, you know, resonate to the same thing. The idea is to segment them into smaller audiences that you can then authentically connect with.
Yeah, I mean, we've been using tools like Node Excel's like a social network analysis tool, and looking at kind of sentiment of audiences and trying to, you know, operate with that. But we struggle a little bit to try and get the data into the right format and try to understand those things. Tribe looks like it's done a super job at understanding that. And I suppose from a marketing perspective, understanding those personas and, you know, what makes people tick authentically, as you say, is critical, isn't it? And again, that shift in landscape, because it's not, you know, those personas and those challenges for people change pretty rapidly, don't they? So we need that kind of real-time information to be able to understand, you know, what are the, you know, geopolitical shifts or the trend shifts or whatever. So having your finger on that pulse of audiences, I think, is right on the money, I think. We've got a question comment here as well, saying, fascinating what is actually possible in this area. Is the ultimate idea to be able to frame the message in different ways to different tribes so it makes the message optimally effective?
Indeed, and not just to tailor the message in different ways to different tribes, but it's choosing the tribe that you want to make the change in and probably removing the other tribes from seeing your message as well. That might be one go-to-market strategy. The other strategy is, yes, tailoring the message to the tribe. And in that case, you have to choose how you speak to each of them. Tribe, if you ask it, it will. You can upload your campaigns, you can upload your videos, you can upload your text, and it will tell you how much it resonates with a particular tribe. So you can know more and understand the impact before you even go to market.
Fantastic. Thank you, Dora. I had a question for all of you actually as well, about kind of careers in AI as well, because I mean it's really interesting, Dora. You know, your new role as a chief AI officer, I imagine, is a relatively new kind of role as well. So I'd be interested to know how you came into that role, and then from Bin and Adam's perspective, I suppose you're all coming from slightly different angles where AI has become part of your work and career. So I'll just come to all of you to just say a few words on how AI has been useful to your career, or indeed if you've got any advice for anybody watching about how they might capitalize on the sort of growth of AI within their own career development. So maybe I could start with you, Dora.
Of course, AI has always been a passion of mine. I've actually completed my degree in 2007 in computer science, but my project was in the area of artificial intelligence. Now, in those days, we struggled and we actually begged a hospital in Germany to give us some data to actually analyze because the data sets were not big enough. Well, fast forward a couple of decades, and we are now seeing that everyone on their phone have got more data than we used to have in those days in universities. So it's the shift and the growth in data is fantastic. Now, what I've done is I've spent loads of years doing software engineering, but I've always sat close to what we used to call machine learning or data science. And then from there, with the explosion of AI, it was only natural that my team migrated into AI, and the engineers and the data scientists that we now employ became AI engineer and scientists. Obviously, I've migrated down the business part, but there is the need for AI literacy and the need for AI optimization in any organization is huge at the moment, and there are very few people that can navigate that. And you'll find us in the chief AI officer jobs at the moment. So yeah, that is my career path.
That's brilliant, Dora. So I suppose as computer scientists, AI's always been quite critical, but to a lot of people now and a lot of organizations now, it's really coming onto their radar in a much stronger way, isn't it? I suppose, and that in turn is going to create more job roles. So I think we'll probably see more chief AI officer roles popping up then, Dora. I think that's really interesting. Bin, what about yourself? What kind of what impact has AI played in your career, and what advice would you give to people that are thinking about careers in AI in different types of ways. Over to you, Ben.
My background is electronic engineering, and so I never learned AI during my study. But from 2019 and 2020, I can obviously notice this kind of trend of change, and particularly from the projects I'm involved, and the founder has requested more and more AI training to facilitate the training and the result. From that point, I start to work closely with two different kind of companies. For example, Passion for Life Healthcare and the Vision Metrics. And Vision Metrics, they are the AI companies, so they force me to work together with them to create the hardware and get some more imaging to help them for imaging training. And for Passion for Life Healthcare, I think for this company also, it's not the AI trained company. However, the local SME has to embrace the new AI technology. So the company started to work together with me, and then we built up a lot of, based on University of Chester support, we set up a lot of sustainable PhD program. For this one, I think four of my PhD students, they are started from the AI training to help the company to develop the algorithm and the products. So from these two typical examples, you can say, I must transfer my skills into the AI part, focus on more my research based on the AI to guide the other part, for example, electromagnetics and electronics.
That's brilliant, Ben. Thank you so much. So it's great to see the university have been able to be sort of agile and morph into that area, but as a quite practical focused prof working with companies and grant funding, you've seen quite quickly there are opportunities and you've been able to capitalize on that. And thankfully, Adam, I suppose, as one of our University of Chester graduates, is perhaps a little closer to to what's been going on recently through his studies as well. So maybe, Adam, you could say a few words about how AI has been useful to your career, or and what advice you've got for other people who are perhaps a little further behind you on the career ladder, Adam.
Absolutely. Like Ben, I'm electronic and electrical engineer by trade, but it's thanks to the University of Chester sort of hybridizing the undergraduate courses with computer science that I was able to gain exposure to artificial intelligence, robotics, control systems. It's really blending the two sort of spheres into one, so to speak. And when I first started as an engineer, it was very much embedded systems, electronics, then going into firmware, then going into software like embedded computing. And as of late, I've seen the emerging field of edge AI, edge computing, tiny ML. It has a lot of different names, but it is emerging where these AI models are being put on device. And so as an engineer, I now have to take off my electronics cap and put on my designer cap, where I'm a computer science, machine learning expert, firmware expert, electronics expert. So my advice would be to be open to learning new tools and new techniques, learning a bit about computer science, a bit of Python, maybe a bit of TensorFlow or PyTorch, learning a bit of how embedded systems works, how computers work. It's all very useful and allows you to become a more flexible engineer in this new industry.
That's brilliant, Alan. So it's almost like the T-shape of skills, but in all your cases, you've used your education and been able to develop that T-shape of skills to then apply it to these amazing case studies. So thank you so much, Bin, Dora, and Adam. You've all been absolutely brilliant. So also, any final words? It's really good to see that your school has kind of been able to provide that foundation and agility, I suppose, to be able to provide these amazing case studies. So any final words from you, Toyosi?
Yeah, thank you, Alex, and thank you to all our speakers. So for our school, one thing we are famous for, particularly from the recent NSS results, is the academic support that we give to our students. And we've actually showcased a bit of that today, because a couple of my colleagues have been here to actually present the content of their research and work that they do. So what I just want to say to our audience, because I'm aware that some of our audience may be prospective students, is that the quality of presentation that you've seen today is what we actually replicate in the delivery that we give here at the University of Chester. And yeah, we look forward to seeing you in the next session next week, as well as other possible interactions and communications you may be willing to do with us at the University of Chester.
Thank you so much, Toyosi. So there's the actions then. Obviously, make sure you've registered and put all the final diary date in there, which is final session 5 on the 9th of September. Make sure you're following us on social media, LinkedIn, Facebook, YouTube, etc. So thank you to all the speakers again. It's been a really informative session, and I love the fact we're getting into the detail of some of the applications of these fantastic case studies. And we look forward to seeing you on the 9th of September. Thanks, everybody, and see you soon. Bye.